You're going to have to after somehow.
Can we find that cheat sheet here?
It's the last slide of the notes.
Oh, okay.
Yeah. All right, so a rational function. We talked about a rational function. It kind of looks like this. And we'll talk more about graphing on Wednesday. I have a whole lesson on graphing and practice and all that good stuff. Some kids like to call it looks like a boomerang. Okay, fine. They're like two little boomerangs. That's fine. Our asymptotes here are the x and y axis in our parent function. What are the asymptotes again? X and y. Our function gets really, really, really close to, but does not what? Does not touch. That is where the function does not exist. So we're going to work on moving our little boomerangs. We're going to go left and right, up and down. Those are called horizontal and vertical shifts. You guys already know this. We're good to go. The domain of the rational function is the set of all real numbers except x values that make the denominator what? 0. So again, where do we look? Where do we focus on? What do we have to look at to find out what our domain is? Where? Where do I look? In the denominator. Okay? So let's talk for a minute. Our domain review. This was in section, I believe it was 1.2. This was on our 1.2 to 1.6 test. This is not new. You guys have seen this year. If I have just a polynomial that does not have a denominator, it can have 42 exponents, anything like that, all real numbers. We can put anything in, get anything out. But there's some instances where we have to say, oh, wait, there are restrictions. If their variable is in the denominator, remember we set the denominator not equal to 0. Like if I had 1 over x plus 2. What's the only number, bad color. What's the only number that you guys cannot use in this function?
2, -2.
Why?
Because that equals 0.
Good. When I plug in -2 plus 2 is 0. Then I have 1 over 0, undefined, no good. All right, if there's a variable underneath the square root, what do I do? Nope, underneath. If I just have a square root, can I take the square root of a negative number? No, I mean I can, but I'll get an imaginary answer. I only want real stuff. So that's where we have that greater than or equal to 0. If the square root, remember, is in the denominator, is it greater than or equal to, or is it just greater than? Why? You're right. Tell me why.
Has to be more than 0.
Has to be more than 0. Good. Good. Okay, good. All right, so if I said to you guys, and this is where I'm going to keep referring to my cheat sheet. It's not really a cheat sheet. It's just a bunch of things condensed to remember what you need. But when we say to find the domain, guys, refer to that if you don't remember. Where do you look to find the domain? In the denominator. Since I just have a variable in the denominator, I don't have a square root or anything, I set the denominator not equal to 0. So only thing that matters here, x minus 4 cannot be 0. What can x not be?
4.
Positive 4. What happens when it is?
It equals 0.
Then it equals 0. Good. Okay, let's look at the next one. Art, what's up? Yep, that's fine. You can do interval notation, either one. Unless Miss Perez is making this test, so if I'll look at it, if she says to write an interval notation, then we'll just do it that way. But again, guys, find the domain. Find the domain. Find the domain. Find the domain. What matters about domain? The denominator. So I would say x squared minus 36 cannot be 0. Okay, I'm going through this quickly because I'm just showing you. We'll do the graphing tomorrow if we have time, but definitely Wednesday, I promise. I just want to focus on these concepts right now. Correct. Look at you. See? Good. Good. You need to be more confident in yourself. All right. Here we're going to talk about shifting. We're going to look at asymptotes. Vertical asymptotes. Vertical. What kind of a line is that?
Up and down.
Up and down. Good. Horizontal is what? Left and right. Guys, if I have a vertical line for $1 million gajillion, is it x equals or y equals?
A vertical line, x equals.
Good. You just won $1 million gajillion. Can you donate to the school so we can get Monday off after Thanksgiving?
No.
Okay. Think about it. A vertical line. Excuse me?
Did we already get the Wednesday goal?
No, not yet. If we have a vertical line goes through what axis? X. That's why it's x equals. So my horizontal asymptote is a horizontal line. What axis does a horizontal line go through? Y. On your test, guys, if you tell me that you have an asymptote at 3 and you don't write x equals or y equals, I'm taking off 92% of the points. I don't care that you guys can find a point on the axis. I don't care that you can divide 4 divided by 2 if the case. I need to know that you understand that it's either the vertical or the horizontal. So looking at this, we're going to go back to chapter 1 when we talk about our shifts. If I have 1 over x plus 3, the 3 is with the x, correct? So what this is saying is it's taking our rational function, our white, see my white, and I'm moving it which way? 3 times to the left. So do you guys see that is our vertical asymptote. Now algebraically we're going to find those as we go through here. But I just want you to visually see what it looks like. We're going to graph more on Wednesday. In this case, if you were just given this equation, I have an x minus 2 in the denominator, and I have a plus 1 at the end. What does the plus or minus at the very end always mean? Up and down. Good. The x minus 2 in the denominator tells me whether I move which way? Left and right. So do you see, just visually, do you see how I took those white, quote-unquote, boomerangs, and I moved right 2 and up 1 with my horizontal asymptotes? Do you guys see that? Like visually. So what that means is the graph, the function does not exist at x equals what? 2. Good. And y equals? Good. What's the domain? What can x not be?
All except 2.
Everything but 2. Good. See, this is all stuff you got. We're good. We're going to get into a little real life, little hairier stuff. Again, we'll get to graphing on Wednesday. Don't freak out. But look at this first picture. Where did they get those vertical asymptotes from? From the denominator. Good. X squared minus 9. Can you factor that? Yes. Plus minus 3? So look, I have a vertical asymptote at negative 3, vertical asymptote at positive 3. We'll go over Wednesday how to find what direction to draw everything. We're going to plug in points and kind of see where it goes. But do you guys see that? What you're going to need to do is when we give you an equation and say, what are the vertical asymptotes? What are the horizontal asymptotes? What is the slant asymptote? You need to know where to look. You need to know if I look in the numerator, if I look in the denominator, how to solve. That is going to be your biggest thing is remembering. And the only way that you guys will get better at that is with practice. We're going to do 2 together so you guys can see. This is what I mean by horizontal asymptote. On my little cheat sheet, I said you compare the degrees of the numerator and the degrees of the denominator. Degree, what does that mean? The highest exponent. Very good. Guys, as I do your practice problems, as I do your test review, I still do this. They talk about horizontal asymptote. The first thing I'm going to do is say, ha, because it's a horizontal asymptote. Is that a y equals or an x equals? Horizontal. Goes through what axis? Think. Goes through the y. So it's going to be y equals something. So you need to compare the degrees of the numerator and the denominator. What is the degree of the numerator? What is the highest exponent that you see in the numerator? 1. I literally will write down a 1. And then I look at the denominator, and now the highest degree is what? 2. So I literally write down the 2, and then I complete that statement. Is 1 less than, equal to, or greater than 2? Less than. So look at your little cheat sheet. What happens when the numerator is less than the denominator, the degree? What's your horizontal asymptote?
0.
It's at 0. Look at it. Look, scroll all the way to the end and look at it. So I know that this graph, when it's graphed, this function is going to have a horizontal asymptote at y equals 0. That means it's going to get really, 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 really close to the y-axis, but what? Not touch it. Good. So look in this case. This is one that always confuses us. Compare the numerator degree to the denominator degree. What are they? It's the same. So you should then, once you notice, okay, it's the same. So that means I have a horizontal asymptote. I have to take the numerator coefficient, which is what? 4 coefficient. That's where you guys are going to get confused. And divide it by the denominator coefficient. What is 4 divided by 2? That's where we got our y equals 2. So when I say horizontal asymptote, this is where we need to practice 100 times to say, okay, what do? I compare the degrees. What happens when it's greater than? What happens when it's less than? That sort of thing. In this case, look at your degrees. Numerator degree is greater than the denominator, so that means what? No horizontal asymptote. Victoria, can you hit close, please, on that box? It's driving me nuts. Thank you. All right. This right here, horizontal asymptotes occur. N is less than M, then the graph is a horizontal. This is exactly what I put on your cheat sheet, guys. It's the exact same thing. It's right here from the book. That's what it looks like. Again, these are just a bunch of examples. We're going to I want to go to the end and do a complete 2 examples with you guys. Yes, sir?
Did you go over arrow notation?
We'll do that on Wednesday. I'm not trying to jam a million things at you at one time. Okay, you guys see these examples? It's just what I want you to look at. We'll talk about symmetry and all that. Talk about graphing on Wednesday. I want to make sure that you guys get this in your brain. Slant asymptote. On your little cheat sheet, what did I tell you? How to find slant asymptote. Use what? Long division. Your slant asymptote is going to be a line. The only thing, and we're going to do an example, so relax, but the only thing that matters is this part of your division. You don't have to worry about the remainder. Your slant asymptote is your y equals mx plus b, that line. All right, so go here. I want to go over some things. You guys can see. All right, when you talk about the domain, what is the domain of a function? X values. We had some areas or some instances in, I think it was 1.2, 1.3, where we had restrictions. When do we have issues? When is it not all real numbers? Square root in the denominator. Good. What else? Think about denominator. What can the denominator not be? 0. So if I ask you on any of these rational function questions, and the question's going to say, what's the domain of this function? Where do you have to look to find the domain of a function? In the denominator, okay? So it's a little cheat sheet saying, so you think, okay, domain, denominator. We're going to talk about vertical and horizontal asymptotes. Does anybody know what an asymptote is? Anybody remember from Algebra 2? It's okay. Yes, sir.
A direct path that, because like obviously certain, I don't want to say shapes, but like lines, like a parabola or the little twist or whatever, or cube. Certain ones like that, asymptotes are kind of like a straight line representing the direction of where that one would be going.
Okay, I like your thinking. Lauren, you wanna?
Because it's not like it's not following it exactly, but it's going through a path of best fit.
Okay,
Curves going
boys.
across a line.
Okay, our rationals. Okay, you can look at it as opposite curves. Okay, that's fine. But an asymptote is a vertical or horizontal line that denotes where the graph of your function does not exist. It's a vertical or horizontal line that when you graph, you'll get really, 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 really close to, but not touch. Okay, we'll talk about that more. But I'm telling you here, how do you find vertical and horizontal asymptotes? How do you find the vertical asymptote? Read what I wrote. What does it say? Read what I wrote. Set the denominator equal to 0. When I talk about horizontal asymptotes, we're going to compare degrees of numerators and denominators. What is the degree of a function or a polynomial? The highest exponent. Good. So we're going to compare the degrees, and it's either going to be that the numerator degree is bigger than the denominator, then something happens. If the numerator degree is the same as the denominator, something happens. And if the numerator is the degree is less than, then something happens. Okay. Then I'm going to ask you a question that might say, what is the slant asymptote? What did I tell you? How do you find the slant asymptote? You use long division. It's going to be a line that goes through our rational function. It's our slant asymptote. The function's getting really, really, really close to, but not touch. When I talk about x-intercepts, guys, what is an x-intercept? Where the graph does what? Touches the x-axis. How do we find the x-intercepts? How do you ever find x-intercepts? Equal to 0. 90% of the time, we're going to do what when I have like x squared plus 2x plus 3? We're going to factor. It's our favorite thing to do. Factoring is never going where? Never, ever, ever. Don't want to do this here. This is how I expect you to do your practice problems tonight. Again, the problems I put up, I didn't like, so I'm going to redo them at lunch. But you should do every single problem algebraically. Again, we'll talk about graphing on Wednesday, but algebraically, you should do every single problem with this little cheat sheet right next to every problem. It will remind you where to look, when to look. If you keep doing that 1,000 times, it's like taking 1,000 ground balls or practicing an instrument a lot, or your drama play or something like that. Thank you. You have to remember where to look at what time, what you're looking for. So if I look for the domain, we're doing this problem right here. I'm looking for the domain. We're doing this problem. Right? Look at your cheat sheet. This is how I expect you to do your homework tonight. Okay. How do you find the domain? What does it say to do? What does it say to do? Set your denominator not equal to 0. So I'm going to say, okay, x squared minus 4 cannot be 0. Agreed? Now you can either factor that or solve it. Move the 4 over, take the square root, or it factors into x plus 2x minus 2. But our domain is all real numbers except what? Plus or minus 2. Whoa, I'm not sure what that was. Another way you can look at that is you can say x cannot be plus or minus 2. Make sense? You guys with me? There's nothing incredibly difficult. It's just a matter of remembering, oh, geez, where do I look? Vertical asymptote. First thing I would do to remind myself, I think a vertical line. A vertical line goes in what direction? Up and down. It goes through what axis? So I'm going to so I remember. Got to remember. So look at your cheat sheet. What does it say to do? How do you find the vertical asymptote? Oh, it's the denominator again. We already did that, didn't we? Yeah, so you're going to answer it as there's a vertical asymptote at x equals plus and minus 2. That means when you graph it, you're going to have a dotted line at 2 and a dotted line at negative 2, right? We're not worried about graphing right now. But you have to answer. If it's vertical, it has to be x equals. If it's horizontal, it has to be y equals. Has to. All right, now let's go down. I need my horizontal asymptote. Think about a horizontal line. It goes through what axis? Y. So go, y. Got to remember it's y. Now look at your cheat sheet. How do you find a horizontal asymptote? Degree of the numerator. Right? So the numerator degree is 2. The denominator degree is 2. What sign goes in the middle there? Equals. 2 equals 2, correct? So when the degrees are the same, what does it say to do? Leading coefficient of the numerator, which is what? Leading coefficient. 1. The number in front of x squared. And then the leading coefficient of the denominator. So I have a horizontal asymptote where? At y equals 1. Perfect. So when I graph it, right, I have at negative 2 a vertical asymptote, at positive 2 I have a vertical asymptote, and then I have a horizontal asymptote at 1. So right away you're getting a picture of what your curves and stuff are going to look like. And again, I'll show you how to do this. It's really easy. You just plot points.
What was the 2 equals 2?
The what?
What was the 2 equals 2? Like, where did that come from?
The numerator degree and the denominator degree. Mm-hmm. Good. Ask questions now. All right. X-intercepts. How do you find the x-intercept? What? What?
Numerator.
The numerator. We've been looking where the whole time? Denominator. For x-intercepts, you look where? The numerator. So what is my numerator? X squared. Hold on. Numerator. X squared minus 5x plus 6 set equal to 0. Well, ladies and gentlemen, are there two factors of positive 6 that multiply to give me positive 6 but add to give me negative 5? -3, -2. So I have intercepts at x equals what? Yep, 3 and 2. What does that mean? That's where the graph does what? Where it touches the x-intercept. Good. Is this terrible? I mean, it kind of is a little bit, but it's not too hard. All right, now if I want, okay, it says, oh, I need the slant asymptote. Here you go, babe. I need the slant asymptote. I'm almost done. Look at your cheat sheet. How do you find the slant asymptote?
Okay, I'm the long division.
Long division. So what goes on the inside? What goes on the outside?
X to the second minus 4. Oh, sorry, I didn't see that. X minus 2 on the outside.
X minus 2 on the outside. What goes inside?
2x to the second power minus 5.
2x squared minus 5x plus 5. Guys, long division. It's not going anywhere right now. X into 2x squared. So x times what gives me 2x squared? 2x. Where do I put that? Over the 5. Good. Now multiply. 2 times x is 2x squared. 2 times -2 is minus 4x. Before I subtract, what do I have to do? Distribute, distribute, distribute. So what's negative 5x plus 4x? Negative x. What happens to my 2x squareds? Good. And then what do I do with the 5? And then we do long division all over again, right? So first term into first term. X times what is negative x? -1. So minus 1. Now, somebody last period said, now you can stop. Is that true? Why not? What does the remainder matter in slant asymptote? No. Nope. You can finish if it just makes you feel better. So I have -1 times x is negative x. -1 times -2 is positive 2, right? Right? And then I distribute, distribute, distribute. So I have leftovers 3. But that doesn't matter. The only part of your slant asymptote that matters is the line mx plus b. So you would have a slant asymptote at 2x minus 1. It's not set equal to 0. You want the line. What would the slope of this line be?
2.
Yep. What is the y-intercept?
-1.
-1. Good.
Is that part of what we need to know in the list too?
It's on your list. There's holes on there, but just disregard that. We're not going to do holes on this test. So we're going to do graphing practice, guys, on Wednesday. Tonight, I'm going to post at lunch because I have lunch next. I'm going to post what I need you to work on. I'm going to tell you how. But please, this cheat sheet is so important. Don't look at it again tomorrow. You need to look at it tonight and practice this. Because these are easy points to get, but it's also really easy to mess up if you look in the wrong spot. Sound good?
Do you cross out the part about holes?